This is AP Calculus, Unit 6 Pretest Solutions. Let's jump right in. So consider the differential equation, this guy, and on the axis provided we're doing a slope field. All right, so let's go for it. So this says that the slope is equal to this equation. So we just need to plug in each of these coordinate pairs. So I'm just going to start in the top right. That's generally where I like to start. It's up to you. So I'm going to plug in x equals 1, y equals 3. X equals 1 is going to make everything, actually all of these are x equals 1, so all of this is going to go away essentially. It's 1 times everything, and I'm really worrying about y. So at y equals 3, this is going to be a slope of 1. At y equals 2, it's going to be a slope of 0. And at y equals 1, it's going to be a slope of -1, because 1 minus 2, which is -1. And at 0, this is going to be -2, so even steeper slope right there. Okay, now let's go to x equals 0. If x equals 0, 0 times anything is 0. All of these are going to be 0. All right, and then finally x equals -1. Again, -1 to the power of 4 is going to be positive, so don't worry about the x coordinate, only worry about the y coordinate over here. So y minus 2, and in fact, since we only have to worry about the y coordinate, just like we did over here, it should be the same as over there. So just copy down slope of 1, slope of 0, slope of -1, slope of -2. I can make that a little bit steeper, slope of -2. All right, how do you score this thing? This is 2 points, so if you got all of these points, it kind of makes a across all of those correct, give yourself +1. If you missed any of them, then you don't get the +1. And the rest of them, if you have the correct slope, so these should both be a slope of +1, slope of -1, slope of -2. If you got all of those correct, give yourself another +1. So +1 is for 0 slope, and a +1 everything else. You don't need to copy down this part. This is just making it more explicit on how to score number 1, part A. Moving on to part B. So we're trying to find all of the xy points, so we need some relation where slopes are negative. So how do I make this entire thing negative so that the slope equals a negative? What do I have to do here to make it negative? And you can use the graph to kind of help you out, but we can just use the equation. It's a little bit easier. So what does this thing need to be or how can I change this variable? And you'll notice that if it's to the power of 4, it's always positive. And then there's one exception. So except x equals 0. So we'll have to account for this x equals 0. Say, like, as long as x doesn't equal 0, then we just have to deal with this half. So if this is always positive, the question is, how do I make this thing negative? So I need to make this thing negative. So to make this thing negative, I basically just need to solve for where y minus 2 is equal to 0. That happens at y equals 2. Therefore, if y is 2 or less, then I'm going to be negative. So if y is 2, not 2 or less, it has to be less than 2. So if y is 1.9, 1.9 minus 2 is a negative. So I need to say something along the lines of, if x is not equal to 0 and y is less than 2, then you can say slopes are negatives. And usually for slopes you can say dy dx is negative is less than 0. So if you have x not equal to 0 and you have y less than 2, then give yourself 1 point plus 1. On to part C. So now we're finding the particular solution. So this means we're doing all the work that we've been talking about, where we separate, integrate, and evaluate. All right, so first step. Step 1 is separate. Separate. All right, so we need to have a fraction equal to a fraction, which we now do, and then we're going to cross multiply. So we have 1 dy. 1 dy is equal to, and then all this stuff is going to be x to the power of 4 times, it looks like a 9, so I'm going to change it, x to the power of 4 times y minus 2, all of that dx. You'll notice that our y is on the right when our x's should be on the right, so I need to move this y minus 2, all of it, to the left-hand side. So this is now going to be 1 divided by y minus 2 dy is equal to x to the power of 4 dx. All right, we have officially separated. Now we need to go to step 2. Step 2 is to integrate. Integrate. And when I integrate, I don't like fractions, so I'm going to anti-quotient, or I'm going to just move this to the numerator and get rid of the, or turn it to the -1 power. So this is going to be the integral of, now it's going to be y minus 2, all of that to the negative 1 power, and that's going to be dy here, and then equal to an x to the 4, integral of x to the 4 dx. All right, now I can actually do the integral. So let's take a look inside here. Dinner is 1, therefore we don't need taxman, we don't need to use u substitution. And I'm going to add 1 to here and I get 0, and you can't divide down by 0, so this is going to be the natural logarithm. So the natural logarithm of absolute value, don't forget your absolute value. If you don't have the absolute value, you lose a point here. Y minus 2 and absolute value, that's going to equal, and I'm going to go up a power, x to the power of 5, then divide down 1/5, and don't forget your constant of integration. And finally, we have step 3. Step 3 is evaluate. Evaluate, which just means we're using x and y in this, yes, x and y. So both x and y are 0, so just plug in 0. So we have natural logarithm of 0 minus 2 is equal to 1/5 of, this is going to be 0 to the power of 5 plus c. And there is a step 4, but I'm not going to do that until the very end of the video, just in case you want to see how to do that extra credit. So how do you score this thing? You get plus 1 point if you are able to separate the variables to this step. You get 1 point if you are able to get the natural logarithm of absolute value of y minus 2. You get 1 point if you get 1/5 of x to the power of 5, or x to the power of 5 divided by 5, simplified. And you get 1 point for your constant of integration, 1 point for your c. And you get 1 point for plugging in zeros for x and y. And you'll notice here that we had 1, 2 points, 3 points, 4, 5, 6, 7, 8 points. This question on the pretest is out of 8 points. Out of 8 points, and I will show you how to get 9 points at the very end of the video. On to problem number 2. So we have this equation that describes the rate of the weight of a baby bird, and we know that the baby bird starts out at 20 grams. All right, so let's go ahead and answer question A. Gaining weight faster. So it's talking about this rate, dB dt. Is this thing bigger or smaller at 40 or at 70? So literally all we need to plug in is 40 and 70 into this equation to see which one is bigger. So the way that you formally show that, and you don't have to show it like this, you just need to get those answers. dB dt at the value of b equals to, we'll do 40 first, that's going to be 1/5 of 100 minus, and then I'm plugging in 40 here, and that's going to be 100 minus 40 is 60. 60 times 1/5, that's going to be 12. So this is equal to 12. And then dB dt when you have b equal to, our other one is 70. That's going to be, we're going to just plug it in, 1/5 of 100 minus 70. It's going to be 30. 1/5 of 30 is 6. So this rate is bigger than this rate. So you can say, you can just write out in words too. You can say bird gaining weight faster. What do we want to say here? When it weighs 40 grams. And if you want to say that in math, you can say these symbols. You can say that, and this is kind of also long to write out, so I don't know which one you would prefer. dB dt at b equals 40 is greater than the rate of this one. This is at the other rate, dB dt evaluated when b is equal to 70. And this implies that 40 is the answer. So you say this implies b equals 40 has faster rate. Okay, cool. So how many points do you give yourself? So you have to use these. You have to somehow get 12 and 6 by plugging in. So that's +1 if you can get these numbers, and then your conclusion where 40 is the faster rate, that's another +1. And on to part B. So we're using the second derivative to explain why this is wrong. All right, so we have the first derivative, and this is a little bit tricky to get from the second derivative to the first derivative. So let's analyze what this thing even means. So if I have d squared, capital B, dt squared, this is really the same thing as saying d dt of or times db dt. And you'll notice this thing right here is given to us, db dt, and notice how this actually works out in terms of the symbol. So if you multiply across, you have two d's, d squared b, and then two dt's on the bottom. It would kind of be like this, dt squared. So this is really how you need to think about it whenever you're going from the first derivative to the second derivative. And we know this guy, we know db dt, we don't know d dt of this. So we need to take the derivative of db dt and multiply that. So this guy, we already know this is going to be, I'm not going to write one, oh, I guess I can write this. I was going to multiply 1/5 through. I think that's actually better. So if I multiply 1/5 through, it's going to be 20 minus b over 5. It's the same thing up here, I just rewrote it. And then what is the derivative of that? And we're going to multiply it. So derivative of this thing is negative 1/5. Negative 1/5. So therefore, when we multiply this straight across, this is going to be negative 1/5 times 20 is a negative 4. Negative 1/5 times negative b over 5 is actually a positive now, b over 25. So this is saying our second derivative is this. So why does it not match the graph? Well, let's use the second derivative test. Let's set this equal to 0 and to see where possible inflection points would be. So if I set this equal to 0, so negative 4 plus b over 25 equals 0. I add 4 to both sides and multiply by 25, and you'll see that b is equal to 100. And using our second derivative test, when we make our number line and have 100, into this equation, what happens when it's less than 100? If I have something like 50, so b is 50, it's going to be 2, negative 4 is going to be a negative value, so negative, and therefore this is going to be a positive because it'll switch over the 100. B is to the power of 1. So what do we know? And we're looking at b over here. This is our axis for b. Between, well, it starts at 20, I guess. It doesn't start at 0. So between 20 and 100, so between here and here, we are concave down. And look here, right here, we're concave up. That's why this thing is wrong. So now we have to use all of our information now to state our conclusion. And our conclusion is d squared capital B over dt squared is negative when x is, well, we want to say it's between something. So x is less than 100, and it technically is greater than 22. I don't think you really need that, but it's definitely when it's less than 100. And so this means, so it should be only concave down, I guess still on that interval, And here's the problem, but our graph is concave up. Concave up. And how do we score this thing? So the first point, we're going to give a point if you can get to this d squared b over dt squared. So if you can get this second derivative correct, this guy right here, then you can get +1. And it might be in a different form. You might get like negative 1/25 of 100 minus b or something like that. But when you have the correct second derivative, that's 1 point. And then some explanation where it talks about how we have a concave up on our graph, but it should only be concave down. That will give you another point. So 1 for the explanation, 1 for the second derivative. And finally, to our last part of our question, part C, we need to use our math to find the particular solution, which means we're doing steps 1 through 3, where we're going to separate, integrate, and evaluate. So step 1 is separate. Separate. So right now I have my fraction equal to kind of a fraction. I'm going to make this all over 5 to make that a little bit easier. So when I separate, I'm going to cross multiply. So I get 5 dB is equal to 100 minus b, that entire thing times dt. Okay, now I notice that I have a b on the right when I should have all my b's on the left, so I'm going to divide everything by 100 minus capital B. So I'm going to have 5 divided by 100 minus b dB is equal to dt. Perfect. I have separated correctly. Second part, we need to integrate. So when we integrate, this is going to be the integral of, I don't like fractions, so this is going to be a 5, and then all of this thing is going to be brought up to the numerator with the negative first power. So 100 minus b to the negative first power, we anti-quotiented, and then that's going to be dB. And now we need to set that equal to the integral of dt. If you don't like dt, you can think of this as 1 dt. All right, now we need to do the integral. So do we need to use taxman on the left because we have a giant thing in parentheses? And we do, because dinner here, the derivative of dinner is -1. It's not +1. So if it was a +1, we wouldn't have to do anything. So we do have to do taxman. So let's find our u. Our equals looks a little bit weird there. We need our taxman. And we need our du. I don't know why the equals keep having a bar there, but whatever. So our u is 100 minus b. Our taxman is knocking at the front door. He's 5. So the derivative of u is a -1, the reason that we had to use taxman. So our fraction that we're going to pay taxman with is -5. So when I pay the taxman, I now have -5. And then I'm going to go ahead and take the antiderivative. So I'm going to add 1. That's going to be 0. I can't divide by 0, which means it's the natural logarithm of absolute value. Always remember the absolute value. 100 minus capital B. And that's going to be equal to the integral of 1 dt. Any constant just goes up to whatever variable that is on the right. So in this case, it's going to be a t. And don't forget your constant of integration, your plus c. All right. So, and that's all we have to do for integration. And then step 3 is to evaluate. And evaluate just means I'm plugging in my t and my b in this case. So when I do that, I have -5 natural logarithm absolute value of 100 minus, and then b is going to be 20, and that's going to be equal to 0 plus c. So how do I score everything? So I get 1 point if I can separate the variables. I get 1 point if I get this entire thing right. I don't get 2 points because this right-hand side was too easy. So plus 1 point if I got both the left and the right side correct. You had to get both correct. And you get 1 point for your constant of integration, plus 1 here. And you get 1 point if you evaluated correct, if you plugged in b and t correctly. And you'll notice that we are 1 point short of the normal 9 points, because if we come back here, that's 1, 2 points, 3, 4 points, 5, 6, 7, 8 points. So this is out of 8 points, just like our previous problem. And I will show you at the very end of this video how to get that 9th point if you do want extra credit. You could possibly get 9 out of 8. On to problem number 3. All right, so we are given dy dx, and it's this. We need to find the second derivative. And remember what I said in our last problem. If I'm given the first derivative, I need to find the second derivative. I'm really doing d dx times, or I guess you can say of dy dx. And we're given dy dx. We know that this thing is already, and I'll just leave it in this form, it's going to be y cubed times 3 minus 2x. I could go ahead and distribute that y cubed into here. I think it'll be easier if I leave it in this form. I need to find this thing with respect to dx, and then plug that in here and then multiply it. So what is this thing when I take d dx of this? So d dx of this whole thing of y cubed times 3 minus 2x. That I think is going to be a little bit hard because there's going to be a quotient rule. Let's get rid of the quotient rule. So this is going to turn now into d dx of 3y cubed minus 2xy cubed. Right, now I'm really just doing d dx of this term and d dx of this second term. So I'm not going to write that out explicitly because I think we can just do that. So what is this thing with respect to x? And this is kind of tricky. So this is where we have to remember we're differentiating with respect to x. So if you see a y, treat that as a constant. Think of this as 3 times 8 to the power of 3. It's not x. It's not a variable that we concern ourselves with. So with respect to x, this thing is just a constant. It's like 3 times 8 to the power of 3. This is just a number. It goes away. Maybe I should do that in a different color to let us know what's going on. And then what is this thing? Think of this as negative 2, that's a weird 2, I could have drawn that better, negative 2x, and think of this y cubed as a number. Think of this as like 8 to the power of 3. So this is essentially saying negative 2 times 8 to the power of 3 times x. So anything with a like this would be a number in front of x, you take the derivative with respect to x. This x is going to go down a power to the power of 1, and you're just left with, I can write this over here, you're just left with, first we had 0, then we're going to subtract our 2y cubed. The x was turned into a power of 0, and therefore it's a 1. So this whole thing evaluates to negative 2y cubed. So now coming back here, plugging negative 2y cubed in here, so we have negative 2y cubed, and this is now going to be a negative 2y to the power of 6, all of this times 3 minus 2x. All right, so we found it. Yay. Find d squared y over dx squared. Find the second derivative. We got it. And we should probably label this so that the people grading this can find it easier. D squared y over dx squared is equal to this thing. And now we have to answer, is the graph of f concave up, concave down, or neither? And then it tells us a point to plug in. So we just basically need to plug that in that point. If it's positive, then it's concave up. If it's negative, it's concave down. And if it somehow gives us a 0 in the denominator, or some weird point that doesn't exist, then it's neither. So let's try that out. So when I plug in 2, so 2 is going to go in for x, and 1/2 is going to go in for y. And remember, we're not actually plugging it in. We're and solving for a number, we just need to know if it's positive or negative. So when I plug in 1/2 to y, is it positive or negative? Y to the power of 6, anything to an even power is positive, and then I have a negative out here, so I have a negative times a positive, so all of this thing is a negative, all of this thing is a negative, and then what about this thing? So when I plug in 2, negative 2 times 2 is going to be negative 4, and 3 minus 4 is a negative again. So negative times a negative, and our answer here is concave up, and then you can be a little bit more formal, at 2 1/2. And then the way to score this thing, you get 1 point plus 1 if you are able to get d squared y dx squared, the second derivative, and you get another point if you have the conclusion concave up or concave down. And on to part B. So we need an equation of the line tangent. So tangent line means we're using y minus the y coordinate is equal to the slope times x, I always do that, x minus the x coordinate, and we're filling in. So we already know what point we're doing. We're doing 2 1/2, so I can write those in here. X is 2, y is 1/2. And what are we missing? We're missing slope. How do we find slope? Slope is this thing. Slope is whatever is over here, and we can just plug in x and y. So let's do that. And the way to be formal about this, and you don't have to be formal, you just need to find a slope, is to say I'm finding dy dx when I say x is equal to 2 and y is equal to 1/2. And there's another way to write this that's simpler, but that's the way I like to write it. And when I do that, I plug it in, and y was 1/2, then cubed. I'm just rewriting this thing, now plug it in. So 3 minus 2 times, and x was 2. So 1/2 to the power of 3 is 1/8. And 2 times 2 is 4, 3 minus 4 is negative 1, so it's 1/8 times negative 1, and our final answer here is negative 1/8. So that is our slope, so negative 1/8, and that's all we need to write. We have our equation done. And how to score this thing. So to score this, you get 1 point plus 1 if you are able to get your slope correctly, so if you got negative 1/8, and you get plus 1 if you're able to get the equation, total of 2 points. And finally, part C for number 3, we are solving. So whenever it says solving or find the particular solution, that means that we are doing our steps 1 through 3. Step 1, again, is to separate, and we know steps 2 and 3, I'll write them out eventually when we get there. So we need a fraction equal to a fraction. Haha, divided by 1. Now it's a fraction equal to a fraction, and I'm going to cross multiply. When I do that, I get 1 dy, and I'm just going to write that as dy, and that's going to be equal to y cubed times 3 minus 2x, all of that times d of x. And I need to make sure that my y's are on the correct side, so I'm going to divide both sides by y cubed, and I get 1 over y cubed dy is equal to 3 minus 2x dx. Perfect. They have been separated. Step 2, integrate. integrate, not groot. From here, we are going to write the integral, and I don't like fractions, so anti-quotient, this is going to be y to the negative 3 dy is equal to, and this is just a normal, I don't have to change anything, 3 minus 2x, and you can think of it just like this, but I'm going to put parentheses and put dx here to be formal. Now I integrate, so this is going to go up a power, so plus 1, and that's going to be a negative 2, y to the negative 2. Don't forget to divide down, divide by negative 2, and that's going to equal all this thing. So I'm really applying the integral to each of these one by one. This is the power of 1, so the integral of 3, and then, and then integral of the negative 2x. So integral of 3 is going to be a 3x, and integral of negative 2x is going to be minus 2x to the power of 2, divide down by the 2, and don't forget your constant of integration, plus c. And for step 3, we're going to evaluate. And all I need to do now is plug in our x, plug in our y, and we get that point. So when I do that, I'm not even going to change anything. I could make this 1 over negative 2y squared, but I'm just going to leave this as 1/2. All of this to the negative 2 divided by negative 2 is equal to 3 times 2, this is going to be minus 2 times 2 squared, all of that divided by 2. I guess I could have canceled out those 2. That's a safe move, plus c. And how do we score this thing? So plus 1 point if you are able to separate. 1 point in total if you can integrate this whole thing. So plus 1 if you got everything there correct. And from there we have, we need our plus c, plus 1 point for the constant of integration, and 1 point if you're able to plug in everything correctly. So how many points do we have in this problem? We have 1, 2 points, 3, 4 points, 5, 6, 7, 8. Yep, so this is an out of 8 points question. And stick around for the very end of the video if you want to see how to do step 4 to separate to get that extra credit, the 9 out of 8 points. And on to the multiple choice, number 4. So which of the following does the limit as x goes to 4 exist? So this is the double-sided limit, so I'm just testing that the left and the right come together. Notice that I'm not actually seeing if it's continuous. I don't care if there's a break here. I don't care if there's a hole here. I do care if there's a gap there, but not for reasons dealing with continuity. So does the left equal the right? So as I come towards the left and I come towards the right, I am approaching that same height. So this one is good, yes. So we'll circle this one. Maybe we should circle the one. Yes, that one has a double-sided limit that exists. Okay, the left here and the right here, they come to the same height here, so yes, for 2. And the left comes up here to this height. The right comes down here to this height. These are not the same height, so not 3. So 1 and 2 are the answers. On to number 5. This is just product rule, find the derivative. This is our first term, our second term. Product rule is 1d2 plus 2d1. So 1 is our x squared, d2 is derivative of e to the x, which is just e to the x, plus 2 is e to the x, and d1 is 2x. Alright, so looks like none of those have that in their answers, but look, we have an x in both terms, and we have an e to the x in both terms, so let's factor out an x e to the power of x, and we're left with an x, and we're left with a 2 in the second term, and c is our answer. And on to number 6, so we have the second derivative is equal to this. It's asking for inflection points. So inflection points happen wherever I have a sign change. So it's f double prime sign change. That is the definition of an inflection point. All right, so sign change means that I need an odd power. I have an odd power here, I have an odd power here, but an even power here, so don't worry about that one. And what critical value will make these have inflection points? So 0 and -1, that's the answer. -1 and 0. Correct answer is C. And on to number 7. So we're looking for a slope of the line tangent. So you see the line tangent and you want to set up the y minus y coordinate, blah, blah, blah. You don't need that. It's only asking for the slope. We don't need to set up the entire equation. So to find the slope, that means we have to have a y prime. And we don't have any y prime. We don't have any dy dx, which means we need to take the derivative to find that dy dx, and then we'll plug in 3, 2 at the end. So let's take the derivative. When we do that, we get a 3, and then this is going to be a times 2y y prime, and now the second term, that's going to be a 4x, that's going to be equal to, derivative of the constant is 0, and then minus, okay, product rule, here we go. So product rule is 1 d2 plus 2 d1, So 1 is 2x, 2x, d2 is y prime plus, and then 2d1, all this by the way is in parentheses because this minus is going to be distributed, and then plus 2, which is y, and then d1 is negative, or we can say, actually we don't need to put the parentheses now that I think about it, because negative 2 is included in in our first term. So 2 is going to be our y, and then d1 is negative 2, y times negative 2, like that. And we need to solve for our y prime essentially. So how do I do that? I have a 6y, let's simplify this just a little bit I guess to make it easier. So this is a 6y, y prime minus 4x is equal to a negative 2x y prime minus 2y. We need all of our y primes on the same side, everything else on the other side. So I'm going to decide just arbitrarily, randomly, to put our y primes on the left-hand side. I'm going to add 2x y prime to both sides, and I'm going to add 4x to both sides to move the 4x to the right-hand side. So what do I have? I have 6y y prime plus 2x y prime is equal to 4x minus 2y. And now I need to factor out our y prime to get it isolated. So when I factor out our y prime, that's equal to, or I have left 6y plus 2x, and that's equal to 4x minus 2y. And from here, it's pretty straightforward. In fact, I probably could have just, as soon as I took the derivative, I could have just plugged in and it might have been easier. But I can get this all into y prime form. Y prime is just equal to 4x minus 2y, all of this divided by 6y plus 2x. And then I'm plugging in 3, 2. So I'm plugging in x equals 3 and y equals 2. And that now turns into 4 times 3 minus 2 times 2. All of this divided by 6 times 2 plus 2 times 3. Now what does that turn into? So that's going to be 12 minus 4. It's going to be 12 plus 6. So that turns into 8 over 18. And that is not an answer, so that needs to be simplified into 4 over 9. And our answer is B. But maybe you didn't want to do all of this math. Maybe you wanted to sub in right at this step, and I think that would have been the smart step. I want to show that. You can skip ahead because we already have the answer. But what if you subbed in? So if I have 6 times, and y was 2, 6 times 2, y prime minus 4 times x, which is 3, is equal to negative 2 times 3 y prime minus 2 times 2. This should be faster, I would assume. So 12 y prime. And I need this y prime to be moved over to the right, and I need this 12 to be moved to the, or this 12 to be moved to the, this 6 to be moved to the left, this 12 to be moved to the right. So when I do that, I'm going to have a plus 6y prime, and this is going to equal to a 12. So I switch those two. Hopefully you're able to catch that. Minus 4, and that's going to be an 18. Y prime is equal to an 8, and yeah, you can see if I divide both sides, I get y prime is equal to 8 over 18, which is what we got right here, and that simplifies to 4/9. So less tricks involved doing early substitution. That's what I would recommend. And our final problem is number 8. So we have the y prime is equal to cosine, so this is kind of like y prime. Then how do we find y? So to get rid of a prime, we need to take the antiderivative. So when I do that, I say the antiderivative of, I guess, antiderivative of y prime is equal to the antiderivative of cosine of 2x, and this will make it y equals whatever. So I need to say y is equal to antiderivative of cosine of 2x, and here I need to be careful because I have to do taxman. So 2x is, the dinner is going to be 2, so taxman, we need a u, we need a taxman, and we need a du. So u is 2x, taxman, there's nothing out front, du is 2, so taxman is going to be paid with 1/2, so this is going to be 1/2, and now I need to take the derivative. So this is going to be anti-change. Anti-change means same sign, so don't change it to a negative, and this is going to be sine of 2x. So 1/2 sine of 2x, do we see that anywhere? 1/2 sine of 2x. Oh, we forgot our plus c. Whoops, plus c. There we go. Now we have the correct answer, which is C. So that concludes the majority of the video. So you can stop here and I'm fine with that. But maybe you're curious and you want to see how would I get those extra 3 points on those first 3 problems? How would I do step 4? So if you want to learn how to do that, go ahead and watch the rest of the video. Let's return to problem number 1. This is where we left off, and we want to get that final point, the extra credit, 9 out of 8. So we want to get rid of evaluate because that's going to mess us up. We want to somehow get rid of this absolute value before we move on. So I'm going to rearrange things, and it's going to look like this now. I moved 2 down here, and we're not evaluating. So I'm going to exponentiate. It's a hard word to say for me. Exponentiate both sides, so it's going to be e to the power of this and e to the power of this. E to the power of natural log will cancel out. I'm just left with absolute value of y minus 2. So absolute value of y minus 2 is equal to, and I exponentiated the right-hand side too. So e to the power of all of this, e to the power of all of this is, I'm just going to write x to the power of 5 over 5 plus c. That's just exponentiated. Okay, now I can go ahead and get rid of this absolute value sign by doing y minus 2 is equal to plus or minus of all of this. And I'm going to rewrite this in terms of e to the power of x to the 5th over 5 times e to the power of c. And it's a rule of exponents. When they're being added, I can separate them and multiply the bases. And I'm also going to switch these two. So I'm going to do that in this step. Y equals, I'm going to add this 2 to the other side. So 2 is now going to be plus or minus, and I'm switching the c here. And the reason I'm doing that, the reason I'm even separating this is because I don't know what e to the power of c is. And I don't know what this plus or minus is. I don't know if it's plus or if it's minus. I have to decide between one or the other. And look, if I switch them, e to the power of c times e to the power of x to the power of 5 over 5, now I have everything that I don't know contained in this little box. I don't know if it's plus or minus. I don't know what c is. I don't know what this whole term is. This is one giant unknown. But we can now solve for this giant unknown because we have an x and a y over here to sub in to solve for this. I'm just going to call it box. I don't want to give it a name. So when I sub in, and I'm going to do that with green to let you know that I'm subbing in, this is going to be 0 is now equal to 2 times that box. I don't know what it is. And that's going to be multiplied by e to the power of 0 to the power of 5 over 5. So 0 to the power of 5 is 0, divided by 5 is 0. E to the power of 0, anything to the power of 0 for that matter, is just 1. So it's going to be times 1. And I have my box. 2 times that box is equal to 0. And look, this is much easier now. It's basically 0 is equal to 2 times x. So I need to divide both sides by, oh sorry, this is not 2. Okay, so there's a mistake here that I'm making. I'm not multiplying 2 here. This is saying 2 plus box, and this can be confusing. So 2 plus box. So this is really 2 plus box here, and this is 2 plus box. And now when I solve, this is going to be box is equal to negative 2. So when I sub in box equals negative 2, this was what I'm going to get out. I'm going to sub that back in for box at this step, and I'm going to get y is equal to 2, and I'm still going to write that plus, but I guess I don't really need the plus because it's going to be a minus. So 2 minus, and I'm subbing in for box now, minus 2. That was the box. And I'm going to need to multiply that by e to the power of x to the power of 5 divided by 5. And that is my final answer. There's no domain restrictions. So if you're able to get this equation, you get another +1, and that was extra credit. And I guess really I should have my other point. Whenever you subbed in for x and y, which happened at this step, this is where we subbed in +1, that's where the other +1 lies, to make sure everything adds up to 9 nicely. That's where I would get it instead of immediately with that first step 3 from back here. All right, so let's move on to our second problem for the extra credit. This is where we left off, and we're going to do the same thing. Don't evaluate it. We need to do some trick here. Let's rearrange things to make it look a little bit better. And now we begin. So we have this thing, and we need to somehow solve for c. So again, I'm going to divide both sides by -5. I'm going to just try to get rid of natural log, try to get rid of this absolute value all in one go. So when I do that, I'm left with natural logarithm of absolute value of 100 minus b, and absolute value is equal to now negative t over 5 and minus c over 5. And this might be a little bit counterintuitive. It's like, oh, well, c can be anything. Can I just leave it as c? And the answer is, unfortunately, no. You have to do this. All right, now I'm going to get rid of the natural logarithm. The way that I do that is by exponentiating both sides. So e to the power of this is equal to e to the power of all of this. And when I do that, so I guess I can kind of do that with this step. So I'm doing e to the power of all this is equal to e to the power of all this. And what's going to happen is the e and the natural log will cancel each other out. And I'm just left with the absolute value of 100 minus b is equal to e to all of this. I'm just rewriting negative t over 5 minus c over 5. Now I need to get rid of that absolute value, so it's going to be 100 minus b is equal to, and I'm going to do plus or minus, because that's how I got rid of the absolute value, and I'm going to rewrite this as e to the power of negative t over 5, and very similar to number 1, I'm going to say times e to the power of negative c over 5. And you might be thinking, well, don't rules of exponents say that you can do this dividing? And you can, but that's not going to be helpful because we want to get everything in one term, and if we make we want to get everything unknown in one term, so we have to keep this as a separate part. All right, so we need to move the 100 over and divide by negative b. Let's see if you guys can follow this. So when I do that, I'm going to get b equals. I'm doing 2 steps here. So when I do minus 100, I'll have minus 100 over here, but then times a negative, this will be a positive 100. And then that 100 will be added, well actually, all of this stuff got multiplied by a negative. So 100 minus, and then all of this stuff is going to be plus or minus, and I'm going to switch these two, just like I did in the problem number 1, plus or minus e to the negative c over 5 times e to the negative t over 5. And you might be asking, where did this negative come from? Remember, everything over here got multiplied by a negative, not just the 100. Every single term, and this is one giant term that got multiplied by a negative. All right, so now finally I have my box. I have all the things that I don't know in a single box, and I can do my substitution. Again, my substitution, t was 0, b was 20, so b was 20, and 100. Oh, sorry, my box was drawn a little bit wrong. Let me go back here. My box should just be around my unknowns, not my minus sign too. I accidentally grabbed that. Okay, subbing back in, we have 20 is equal to 100 minus, we don't know what that is, box, times e to the power of, and again, this is going to be negative 0 over 5. Negative 0 is 0. 0 over 5 is 0. E to the power of 0 is just 1. So it's going to be box times 1. 100 minus, and just rewriting the rest of the problem. Cool. Now we can solve this thing. So if I go ahead and just subtract 100 from both sides, I'm left with negative 80, multiplied by the negative again, and 80 is what I get for our box this time. And once I plug in our 80 for our box, I'm left with this equation, b equals 100 minus, and our box now is 80. So this is going to be 80 times e to the negative t over 5, and no domain restrictions. So where did all of our points come in? We got 1 point for separating, plus 1. We got 1 point for integrating, just the left-hand side. Well, all of this really. The left-hand side was the hardest, so plus 1 for integrating. And 1, oh, I guess I shouldn't draw that there. Integrating, you finally get it down here, plus 1, and plus 1 for the constant. And then we also got our plus 1 when we subbed in, so we finally subbed in here, and our extra credit point came from our final answer right here. If you got that perfectly, then you got that extra credit point. And because I'm running out of space, I'm going to go to the next slide over here. So I'm just copying that. What are the domain restrictions? Again, we need to make sure that this thing here is never equal to 0 and never, at least underneath the square root, never a negative. So let's check how to get those conditions so that we can avoid them. So let's go ahead and set this thing equal to 0 to see where it can't ever equal 0. So I need to set this 2x squared minus 6x plus 8. That needs to equal 0. So when I do that, I'm going to factor this left-hand side. 2 times x squared, I'm factoring out the 2, minus 3x plus 4. That's going to be equal to 0. And finally, this thing is going to be factorable as well. So this is going to be minus 4 plus 1, x minus 4, x plus 1 is equal to 0. And finally, I can say that x is equal to negative 1 and comma, x is also possibly 4. So it can't be those things. Remember, we said we'll find what, when you set it equal to 0, what it can't be. It cannot be 1 or negative 1. It cannot be 4. But it can also never be negative. So what we can do here is we can set up our number line. And negative 1 is here, 4 is there. And I'm going to look at this factored form here. And I'm going to see which of these will give us a negative, because it can never be a negative. So if I plug in, let's choose like 5 or something. If I choose 5, this is going to be positive, positive, positive. All those are positive. And remember, each of these is to the power of 1, which is odd, which means it switches over each of these critical values as they are. They're not really critical values. So minus and positive. So it can't be in this interval, and it can't be equal to -1, 4. So your domain restriction, you can say it's equal to this as long as you have these x values. Sorry about that. You can have these x values. So x has to be less than -1, and x has to be greater than 4. You have to have these domain restrictions, and you have to have this equation in order to get that extra credit point. And that will give you your +1 there. And in case you're wondering where your points would come from for over here, so when you separated, that's going to be +1. Integrate, so if you integrate both of these sides, that's going to give you +1 for the c. And wherever we evaluated, so we evaluated right there, so we got that point immediately. And then that last point on this slide, perfect. So that adds up to 1 point, 2, 3, 4, 5 points, 6, 7, wait, that's the old one, 6, 7, and 8, 9. Yeah, so it comes out at 9 points for number 3 as well. So that is the final, that's not the final answer. Yeah, that is the final step for the extra credit in case you wanted to know. Thank you for watching.